Distribution of data such as normal distribution, uniform distribution, bimodal distribution, positive and negative skew. All those things we'll discuss it. In the last section, I will help you understand the measures of variability, which we will take a look at it in depth in tomorrow's session. Tomorrow between 12:30 to 1:30 we'll have a session. On Sunday also the same time we will have the session. Don't miss out. So the measures of variability is also known as measures of spread. As part of this, let's take a deep dive in understanding what is the range, variance, standard deviation, coefficient of variation, and how to apply in business scenarios. That is very much important. So knowing what is mean, median, mode, or range, standard deviation alone is not sufficient. How it helps to make the right decision, how we can apply this in the real business scenario, how we can derive insights, how it is helpful in terms of making the right decision at the right time. So that matters a lot. Alright, first thing first, what is statistics? What is statistics? Can someone tell me what is statistics? Let's make this session more interactive. Okay, I am going to unmute you all. Okay, now you can tell me what is statistics. Don't read it out. So what is your understanding about statistics? Statistics is a branch of statistics. It deals with collecting, interpreting, or classifying the data, analyzing the data, interpreting the numerical facts. And we make prediction also as part of statistics. Okay, so there are two branches are there in statistics at a high level. The one is the descriptive statistics and the next one is inferential statistics. Let's start with understanding the descriptive statistics first. Okay, so and it lets us understand the types of data and different levels of measurement. Before we dive in to understand what is descriptive statistics, okay, so we are going to talk about this before we jump in, right? So there are certain fundamentals you should be knowing it. So if you take any programming language, you might have heard about variable. Variable. What is a variable? As the name suggests, a variable is anything that can take on different values across your data set. For example, you have a column called sex or gender. It's a variable, right? It can take either a male or female value. If you have another example for age, right? So another variable is the age. Age can take any value. So maybe let's say your customer age may be 18 years, or it can be 10 years, or it can be 60 years or 70 years. Right? So now we will try to understand the types of or the scales of measurement. Also we call it as a type of variables also, okay, in statistics. We have something called nominal type of variable, ordinal type of variable, interval and ratio. These are, in general, in statistics we call them as a scales of measurement. Okay? So now the question is, why should I know about the different levels of measurement? Because it helps us to decide how to interpret the data from the variable. So secondly, knowing the level of measurement helps us to decide what statistical analysis is appropriate on the values that were assigned. Alright, so now let us take a look at these four types of levels of measurement. So we have something called nominal and ordinal type of variable or scales of measurement. What is the nominal? So what is a nominal? For example, you have a column by the name of gender, right? Gender can be male or female. Let's say you are given a data set. It has all the order transaction related data, order transaction data in it. So you have something called order date. Let's say in Amazon you order some items. Each order you'll have order number, order date, and customer key, and line item, and you have product key and unit price, and then quantity. Likewise, you have so many columns are there in the Excel sheet, or let's say they've given you the order transaction in Excel sheet, and let's say your management wants to know how many of the customers, how many of the male customers ordered the items or specific product, or if they ask you how many number of Even if you do so, you cannot. So now you might argue with me, sir, in this case, I do some kind of encoding. What is that? Encoding. What do you mean by encoding? Instead of male, I specify male as 1. All the males 1 and female 0. If it is a text value, what you are saying is correct. Male plus female divided by 3, it doesn't make sense. Instead of using the text value, I am going to encode the values of the gender column with these values for males 1 and females 0. Even in this case, if so 1 plus 1 is 2 and 2 divided by 3, can we say something like 0.6? 0.6, on an average 0.6 males order. Can you say that? It doesn't make any sense. Even if you do encoding for the nominal, if you do the encoding for your values of nominal variable, which is nothing but the categorical variable gender, it doesn't make sense if you compute the mean. Please remember, for nominal type of variable, we can find out the frequencies, we can find out the proportions, mean, median, so these things we cannot do it. So next one is ordinal. The ordinal is also somewhat similar to nominal. Then what is the difference between these two? So using ordinal, like nominal, we can categorize the data. Okay, in addition to this, we can rank the data, rank the values in one variable. So we can categorize the data. It can be categorized and it can be ranked compared to nominal. Okay, so nominal you cannot do ranking. Classic example is, for example, appraisal rating. Appraisal rating. So let's say you are working in TCS or Cognizant, they will give you the appraisal rating. For you it's 1, for your colleague 1, and somebody they give 2 and 3 and 4. So 1 being outstanding, 2 is good, very good, and 3 is good, and 4 is bad, poor. Okay, they will put you on NIP, need performance improvement. Okay, need performance improvement, NPI. If you don't perform well, they will put you. So they again will have to start everything from this. So 1 is high, that means you are a top performer. You did a lot of accomplishments, you achieved many things as part of your company. And 2 is, yes, you did it, but it's not as great as what these guys have done it. Okay, so here can I say 1 is greater than 2 and 2 is greater than 3 and 3 is greater than 4? Yes, because the values in your ordinal variable can be ranked. Okay, so and we can compare the values. 1 is greater than 2. Obviously rating 1 is topmost rating. Second is topmost rating than 3, and those got rating 3, they are superior than those got rating 4. Can we do the same thing here? So 1 is male. Can I say 1 is just 0 is female? Just because I have encoded the males as 1, can I say males are superior than females? No. We cannot say males are superior than female. Whereas here, so 1 is, the rating 1 is superior than 2. Those got rating 1, they are eligible for promotion, they are eligible for salary hike. Those got rating 2, they are eligible for salary hike, not for promotion. These guys are also eligible for salary hike, but they will not get much salary than these two guys. Okay, so something, but here we can compare the values, right? So 1 is superior and superiority comes into picture, but whereas here it is not comes into picture. So to conclude, the nominal data or variables, right, can only be categorized, whereas in the case of ordinal, the data can be categorized as well as it can be ranked. Please remember this. Next one is interval. So even the ordinal type of variable is called a categorical, qualitative, non-parametric. So both, in all aspects the same, but you need to remember, with ordinal we can go one step further. and we can do ranking. So other example for ordinal type of the risk, mutual fund risk, high risk, medium risk, low risk. Right? If the risk is very high, right? So nobody is going to invest. And again, they will, they will take a call based on the return. Okay, if the return is more, and if the risk is high, still, if the risk is high, right? You might get higher return, or you may not get any return at all, or right? So you might lose some money, something like that, right? So high is, again here high risk is high, more sensitive than this, and this one is more sensitive than this. This is another example for ordinal type of variable. Next one is the interval. In the case of interval, the data can be categorized and it can be ranked, and it is evenly spaced. It is evenly spaced. I would so the interval is called as discrete variable. You need to remember this. The interval is also called a discrete variable, and ratio is called as a continuous variable. Continuous variable. So what is the discrete variable? Whole number. It is a whole number, and this is this is your. It is not a whole number, as the name suggests. It is a continuous value. For example, in the case of interval, number of defects. You have a column called number of defects in your Excel sheet, along with some products. Okay, so the product A, we got 2 defects, and for product B we got 3 defects, and for product C there are no defects. We never say 2.233 defects were there, 3.33 defects were, right? We specify the values for this type of variable in whole number, integer. So another example, give me some other example. So you have something called number of kids born in a labor ward. In an hospital, there's something called labor ward. In the labor ward, let's say the senior staff nurse enters the labor ward in the hospital, and she is asking, hey, how many male kids born, how many female kids born? The answer could be 5 male kids and 6 female kids. Right? It is not like 5.55 male kids, 6.6 is, right? There are certain variables, it takes only the whole number. You need to remember this. So those type of variables we call it discrete variable. This is a shortcut. Okay, whole number is nothing but discrete variable. In practice we use this term discrete variable. And next one is the ratio. The ratio data can also be categorized, and it can be ranked, and can be evenly spaced, and has a natural zero. It has a natural zero. Okay. So what do you mean by natural zero? Let's say in your bank balance, if you have 0, in your bank balance you have 0. What does it say? You don't have any savings. You don't have any money in your account. But whereas in the case of interval, the same 0, if I say, right, the temperature is 0 degree, can we say no temperature? No, right? But whereas here it has a natural 0, but it is not, here also it has some meaning with it, right? So it is not, the 0 is nothing. In the case of interval, the 0 is considered as some value here, but whereas here it is a real 0. Okay, so 0. Okay. Okay, now we understood. Okay, the example for ratio. I told you ratio is a continuous variable. Salary is a classic example. In the case of salary, the salary need not be whole number, right? It is and then weight of a person, body temperature, weight, and this 101.2 degree, 101.8 degree, and weight is 78.54 kgs. And salary is something like 1,21,000, something like 636 pages, something like that. Okay. So So these are the examples for ratio. Ratio is also called as continuous variable because it is not a whole number. Okay, it is a continuous value. Okay, between 73 to 74, right? Whatever the values are, right, it will take that one. So 73.54. Okay. So these are called your ratio and these are called your interval. Interval is called as a discrete variable. The ratio is called as a continuous variable. Fine. So far so good. Everything is fine. So next we will move ahead with okay. Now you tell me what is the answer for this. So far we discussed about what is nominal. The data can only be categorized. Ordinal, the data can be categorized as well as it can be ranked. And the interval, the data can be categorized, ranked and evenly spaced. Data can be categorized, ranked, evenly spaced and has a natural zero. So these are the different types of measurement we discussed a while back. Now you tell me what is the answer for this. So you have a column called gender. The values can be either male or female or it can be a text value. One is male or two is female. What is the level of measurement? It is a nominal type of variable. Nominal type of variable. Just we are giving the labels for the transactions. Now you tell me what is the answer for this. What is age? What is age? What is age? What type of level of measurement is that? Is that an interval or ratio or is that a nominal variable or is that a ordinal variable? We cannot say 24-year-old guys are superior than 23, right? We cannot say that. 24-year-old guy is older than this guy, but he is not superior than this guy. Alright? See, in Andhra Pradesh, the chief minister age is maybe 48. Okay, right? So, and let's take another person. Let's say in other state, the chief minister age is 72. Just because this chief minister age is lesser, we cannot say this guy is inferior than this chief minister, right? So we cannot say ranking. It's not an ordinal type of variable. Then what type of scale of measurement? What scale of measurement is that? Can you all please make it fast? Let me just the recording is in what kind of measurement? We discussed, right? See, what is age? Can we say age is a nominal type of variable? No, it is not a male, female, it's not a color, right? It's not a ranking. Can we say it is an interval? It's a whole number, right? It is an interval. So can we say interval? Yes, it is an interval. So can we say the age is 23 point, let's say if somebody is asking you what is your age, if you say you are 24-year-old and 24-year-old, you have completed 24 years and 3 months and 22 days. Can you say like that? No, right? Always say your completed age. The whole number is nothing but your discrete variable, which is nothing but in our case it is an interval, right? Okay, it is a discrete variable. It is a discrete variable. It's a discrete variable, and the level of measurement is interval, the age variable. What is hours spent last week? Can someone tell me here? See, if you say I don't understand, then you are not concentrating here. Believe me or not, in the last summer, 12 10th standard CBSE students they attended. They are able to complete all the assignments. They are able to answer the questions then and there. Okay, so it is not a rocket science. Okay, hours spent last week. So here we have decimal value here. So already mentioned it's a ratio, right? So if it is a ratio, what type of variable is that? Discrete or continuous? Can you please type it in the chat window quickly? Can you see the type? This one. Sumati, Jivanandam, Sudeep, and Ashish. Can you please type it in the chat window quickly? I'll just type in hello. I just typed it in the chat window. Can you please say, is that a discrete variable or continuous variable? So I allow participants to unmute themselves. Yes. Can someone talk? So ratio is a continuous variable. Yes, please type it. Yeah, continuous variable. Correct, right? Continuous. Very good. It's a continuous variable. Guys, please motivate me also. Continuous variable. Okay. And the next one is performance rating. I mentioned about rating. Already we discussed about rating. What is the level of measurement? What is rating? Ordinal, rank. These are rank. So it is an ordinal type of scales of measurement. And is that a discrete or continuous? It's a whole number, right? So we can say discrete. So ordinal type of variable, it's a ratio, scales of measurement, and ratio, scales of measurement is a ratio. In this case, this is interval. Fine. Next, we will jump into descriptive statistics. What is descriptive statistics? In a single one-liner, as part of descriptive statistics, we are summarizing and organizing the data. To get a big picture about the data given to you, right, we simply summarize the data. So the descriptive statistics involves summarizing and organizing data, so they can be easily understood. So unlike inferential statistics, the descriptive statistics seeks to describe the data but do not attempt to make inferences from the sample to the whole population. This is the one you need to remember. At this moment you don't worry about it. See, in statistics there are two branches. One is descriptive statistics and the other one is inferential statistics. Other one is in descriptive and inferential statistics. We are talking about descriptive statistics. As part of descriptive statistics, in simple term, we are summarizing the data. Okay, now within this descriptive statistic, there are two branches are there. Okay, the one is measures of central tendency. Measures of central tendency. The other one is measures of spread. Okay, measures of spread and measures of central tendency falls under descriptive statistics. What is descriptive? In a simple one-liner or in a single word, we are summarizing the given data. Whereas in the case of inference statistics, with a given sample, we are trying to infer the population. Okay, that we will discuss it later. Okay, so now we will start understanding what is measures of central tendency. Measures of central tendency falls under descriptive statistics. Take for example, okay, so we use as part of measures of central tendency, we are going to explore the measure called mean. So these are the salaries of different employees or different data scientists salaries. This one, as you aware, let's say you are falling in band 2 and level 6. Let's say in your company, for each position, for let's say in this company, the data scientist falls under the band 2 and level 6. All these guys have almost similar experience, but the salary is not same. That is very common. Let's say you join with Cognizant or TCS or any other IT company, right? So I don't know about other companies, okay? So even though you are a Java developer or data scientist, okay, you are and if you have let's say your experience is between 3 to 6 years, your peers, your colleagues, experience also same as you, but there is a variation between your salary and his salary. Not all the data scientists salary is same, correct? Even though their experience are somewhat similar to you, the salary is not, there will be variation. Fine. If somebody is asking you take an average, okay, and if you add all these values, how many data points are there? 6. This one plus 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 divided by 6. If you do this, you get this value. And what I do is, when I look at this value here, this one seems to be very big. What I do is, I'm not going to include this in my mean computation. I simply remove this. I take an average of only these 5 values, because these 5 values somewhat closer compared to this one. 48,000 to 57,000, there is a the distance is little more, but 48,000 to 500,000 distance too high. So all these values are somewhat closer to each other except this one. Hence I am going to remove this, and if I take the average now, for this the average I am getting, what average I am getting is 48,000. Okay, I'll ask you one question. Let's say you are working with Accenture, your friend is working with TCS, and he is also having a similar experience of you, and he is asking you, hey, if I look out for a job in Accenture, if I make a job switch to Accenture, what is the average salary can I expect it? Will you tell this one to him, or will you tell this one to him? Please type it in the chat below. Don't be shy. Whatever, here there is no right or wrong answer. Okay, it is not that if you give wrong answer you will be punished. You tell me, if your friend who is working with TCS is looking for a job change, he wants to join with Accenture, is asking you what is the average salary can I expect? His experience also similar to your experience. Will you tell this value, or will you tell him this value? No, I am not asking about X bar. No, you will tell this value. Huh? Okay, and okay, iPhone is Sumati, yes. So Sumati says 48,000, and Jivananda. How about others? Others, please type it in the chat window, guys. So okay, just because one person is getting very high salary, you cannot tell your friend, hey, you can expect on an average 123k. Just because one person is getting very high salary, if you include this also as part of this, and if you take an average, your average also skewed. I used a new term called skewed. So what do you mean by skewed? So this average is skewed. This average is skewed because you have a very big value here. You have included this big value along with this other values, normal values, hence the average also got skewed. But if you, after you discarded this value, when you computed the average, it shows this one. If you tell your friend, just because one person is getting very high salary, he can expect 123k, you are setting a wrong expectation. Right? If you exclude him, majority of the guys with your friend's experience, the average salary is 40,000. If you tell him this one, it makes sense. If you tell him, he will be so greedy, and he will he'll attend the interview, he'll clear the interview, and then after the discussion with HR round, right? So if they say 48,000, he can expect, he will be upset. So why this average is skewed? Because you included this bigger value. This is called your outlier. What is an outlier? What is an outlier? Outlier is the somewhat unusually very high value. Unusually very high value. Not only very high value, unusually very low value also, called as outlier. Okay? Either unusually very high value, or if you have very low value. For example, you have something minus 38,000. No employee will get negative. No employees will get salary to company, isn't it? So there is something wrong here. So you have an outlier, which means in this case it is unusually very high value compared to the other values, and this is called outlier. Okay, if you find any outlier, you need to check with your customer. Hey, I could see 500,000. This guy also has similar experience of others. Why are you doing? So if they say, the payroll department, they say, no, no, sorry, mistakenly we put additional zero here. So then you don't have an outlier, and if you include this value also along with the other values to compute the mean, it will be somewhat 48,000 and odd, right? It cannot be this one. Let's say you interacted, you checked with the HR, you are asking them, hey, this salary is too high compared to other guys, is that a correct value? And they say yes. And they say yes because this guy in the past worked with a reputed company like Google. He worked with Google and he joined with Accenture now. And he has got phenomenal experience, right? All the things. They say so many things, because of which we went overboard and got approval to give this help to this guy, because this guy deserves. He filed a lot of patents and he did a lot of things. Because of him, we are able to win a new project. Okay? So this outlier is a valid one. This value is a valid one. It is not a typo. Typo means typing error. Right? So it's a valid. So in that case, you have to include this value also as along with the other value to compute the average. But if I include this along with the other values, the average gets skewed and it misleads me if I use this value. What did I say? This one? This is an outlier. What is an outlier? Unusually very high value. Okay, and something very high value or very low value, if you find it, that is your outlier. But there is a formula to find out the outliers. We will discuss this later point. I don't want to discuss everything in a single session to I don't want to overwhelm you. Okay, fine. So now the situation is, he says it is a valid value. We need to include this as part of this. But if I include this, average is getting skewed. So what is the way out? Can I tell this? No, you cannot use this value. So if you have an outlier in your data set, don't use mean. Don't use. We have another measure which we will discuss it little later. Don't use mean if you have an outlier in your data set. It is as simple as that. If you don't have an outlier, let's say you don't have this value, so in that case you can use mean. If you don't have outlier in your data set, you can use mean. If you have an outlier in your data set, we call that as skewed data. Skewed data. See, if you plot these values in a histogram or in a chart or simple chart, what will happen is your 48,000 somewhat, 48,000, 53,000, something like this. And suddenly you can see a big bump here. This is what your 500,000, right? 500k. So all these values are somewhat here, right? It's somewhat normal, but suddenly you can see it's a skewed data. So the normal data should be something like this. The distribution should be something like this. This is called your normal distribution. Both sides, the tails, it looks like this. But whereas only this side, the tail goes like only, the left side you can see a tail here, but the right side you can see a big bump here, curve here. This is called your skewed data. If you have an outlier in the data set, the data will be skewed. And if you are not supposed to use mean. Okay, in this case, what other measure can I use it? We have something else called median. Okay, before we jump into median, okay, let us work on this interesting quiz. Can you give me an answer for this one, each and every question, in terms of the true or false? All salaries in the distribution affect the mean. Is that true or false? I discussed a while back, right? All the salary in the distribution affect the mean. How do you compute the mean? Let's say you are given 10 numbers. How will you 10 different numbers? How will you compute the average? Add all the values divided by 10, right? So in that case you take into account of all the values. Yes, true. In this case it is true, because To compute the mean, you need to take into account of all the values, right? True. And mean can be described with a formula. Yes, true. Like this. Look here. So you can use a mean. You are using a formula here, right? You add all these values, all the values. When you add it, you get 2000 divided by total number of data points, 10, 275. There is a formula for finding the mean. Is that true or false? It is true. Many samples from the same population will have similar means. This is a tricky question. Let me see how many of you answered it correctly. Many samples. You know what is population, what is sample? So how many of you are aware of this one? This population and sample. Population is the entire Tamil Nadu people. Of the entire Tamil Nadu people, how many of them are Kongu people, Kongu Nadu, Coimbatore people, right? So their Tamil is little bit different. You are taking a subset of the data, that is called your sample. Now you tell me, is that a true or false? What is your answer here? True. Okay, that is, no, it is not true, right? Why do you say it is true? It is not true. Many samples, it's a tricky question, that's why I told you that many samples from the same population will have similar means. For example, I'll give you some values here. I'll write you some values. Let's see, you are given the population as 1, 2, 3, 4. What is the mean for this? 4 plus 3 is 7, plus 3 is 10, divided by 4 is 2.5. This is the population mean. Population mean, we use the notation called mu. Okay, very simple. In school time we studied. This is called your population mean, 2.5. So how did I get this? 1 plus 2 plus 3 plus 4 divided by 4. So this is the one gives me the population mean 2.5. Okay, I'm going to draw a sample. This is my population. I'm going to draw as many samples as well. For example, 1, 2 is one sample. I call it sample 1. And let's say I use another sample 2, 3. I call it sample 2. And I'm going to use another sample 3. And something called 4, 3. What do we call the sample 1? this data set B is little far away from the average. All these values. But if you look at the data set C, it is too far. Most of the values are too far from the average value. Now the question is, why should I learn about measures of dispersion? Knowing measures of central tendency, because learning mean, median, mode is pretty simple. If I know this, can't I say I'm a statistician? Or with this itself, can't I make all the business decision? You cannot. I'll give you a simple analogy. With that, you should be able to understand why learning measures of dispersion is very much important. Let's say you are living in a village, you are running a business in a village. Let's say you have a small shop in a village, okay, and it's a grocery shop. In that village, you have 800 households are there, family, okay, 800 families are there in that village A, I call it village A. You have only one shop, you don't have any competitor. All the 800, most of the customers, right, they come and buy it from your shop only because you don't have competitor. Hence, your business is really good. So nearby, little nearby your village, right, you have another village called B. In that village also people, some people they come and buy from your shop only. But there are some customers, they go to the nearby town and they go and buy it. But when you talk to some customers, those come from village B, you understand that if you set up a shop in this village, can leads to increase in your sales volume or increase in your sales or profitability. So what you are doing is, okay, you decide to set up a shop here, but you don't want to blindly go and set up a shop here. You are a street smart. What you are doing is you are taking a data scientist along with you, and then first you want to go to the village, okay, and then nearby village, and then you want to conduct a market study, market research. Based on the outcome of the research, you are going to decide whether you are going to set up a shop or not. Fine. So you and your friend is a data scientist. Both of you are carrying a laptop, okay, and you are set out to go to the nearby village. But in order to go to the nearby village, you need to cross a stream. You need to cross a river. So on the bank of the river, you both discuss, hey, can we go by walk to cross the river, or can we take a boat to cross the river? You need to make this decision. To make this simple decision, maybe a simple decision, but you are holding an expensive laptop. If this gets drowned in the water, your laptop will get spoiled. So you want to make the decision immediately. What you are doing is, somebody is crossing, a passerby is going on your side, and you are calling him, hey, can you please tell me the average depth of the river? Average depth of the river. And this guy tells you the average depth of the river is 4.7 feet. Let's say this guy's height is 4.9 feet, and this guy is also 4.9. So now what you are doing is, after hearing this average depth, hey, the average depth of the river is just 4.7 feet. We are 4.9 feet height, and when we reach a place wherein the depth is 4.7 feet, we will lift the laptop on top of it so that our laptop will not get drenched. So with the average, measures of central tendency, the average, mean itself, you decided to cross the river. Now your friend data scientist says, hey, hold on, wait. Average alone not sufficient. He tells you, right, what this guy is asking some more detail from this guy. Every 20 feet, can you tell me what is the depth? And he plot, in his mind, he is plotting this. The average is 4.7 feet. The average is there in the middle. And this guy says, first, when you cross first 20 feet, the depth is 1 feet, 1.2 feet, 1.3 feet, and somewhere 2 feet, and somewhere 4.7. And he says, 4.7, and that's all. And somewhere the depth is 6 feet. See? Now, you are asking, hey guy, when I asked you the average depth, you said 4.7, now you are saying 6 feet. Obviously, this guy says, are you crazy or what? Right? You asked me average, I gave you average. If you could have asked me the spread, I would have given you the spread. This is what called your dispersion. Now you understood the distribution is how much important. Right? If you take the average of, let's say you have more 1.1, 1.2, 1.3, 1. Most of the values are small, 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 small. Along with that, if you have one bigger value, and if you take the average, obviously it will show the average will be lesser, right? Average will be lesser. Because you have skewed data. Most of the values are small, you have an outlier. If you do this, your average is skewed, but still you have more small values, so your average boils down to 4.7.